after a full month of rigorous coding, more than a full month. Not actually, I just kind of suck at this, but I have the second part for this, and I need to figure out everything that happened back in time because I finally gotten around to making the video. So I did promise a part 2 to explain how this time, how I actually ended up implementing the daytime system. And so we do have that working now. I can actually show that, show an actual example of that working in real time. And it kind of was a slightly interesting diversion. So I didn't actually end up doing any of the things that I talked about. This is what it looks like, by the way. This is a nice smooth transition between the 4 different states, right? Very nice, very smooth. And this works with everything, by the way, too. If we jump into combat real quick, I can go really fast if I want to, or I can just make it smoothly transition. Here's what I actually ended up doing. All right. So I created a system of secondary objects that basically hold the behavior for this system. And they handle everything that has to do with this system. So rather than using, I forget all the different things I talked about before, but like polymorphism was the one I was planning on going, which means that every single object would have their own function that I would call, and that function would handle things for me. That's close. We have something similar. So one thing we do set up is we do set up something similar to an object, right? Now this has some extra information to it just because of inheritance stuff. Once again, same thing. We've already got a previous, I talked about this last time, where if you already have a previous structure, you can't necessarily you can't upheave the entire table. So because this has a child, that doesn't quite work with everything that we want. And note, if you don't know, inheritance basically means that all of these children underneath get the exact same code from their parent first and run that, which means in this case, the skill node, of course, being a child, will run this precisely, and we don't necessarily want that. In the case of the skill node, we want them to behave slightly differently. So we have a little bit of a check here to just say, hey, as long as I'm not a skill node or anything like this, whoops, we create this daytime color tracker. And then in there, we put down a function, right? And this function is what we're trying to run. So it's similar to polymorphism, very, very close, right? We're basically giving every single object their own individual function, just like I said. So combat drawer, for instance, has a couple of calls to this function that call specific behaviors. Then each of them are slightly different, so we don't want to run the same code every time. Anyway, this makes things very, very easy. We just have to create one of these objects and give it a function to run. What are these things that I've created at first? Let's talk about that first. So we have a global list that we've created, and these functions here are actually little objects. What we're doing is creating a struct of information that has other tiny functions inside of them. So basically, whenever we call that create daytime color tracker, what we're actually creating is a separate object, a separate little, I don't know. What would be a good analogy here? I'm not sure. It's like a little badge, right? They all have their own, it has its own little behaviors, but you could take it off very easily, which makes it very easy to determine what will interact with this system that I've created, right? That was mainly the biggest thing we're trying to figure out, is how do we easily make sure that some things interact with the system, but other things don't? Because not everything should. We don't want everything to invert colors and change their color palette. We don't actually want that. We want some things to, but not all of them. This is a great way of setting it up. If they have a daytime color tracker, well, then of course they're going to have some kind of interaction. But if they don't have a daytime color tracker, well, then they never interact with the system at all. And we don't even need to do a check here, right? We don't have to do like an if-then check to see, oh, are you part of this system or aren't you? It's just simply these will all run, and if they have a linked object attached, they will change their linked object. Because what we actually do when we create this thing is we build the brand new one of these guys, then we add it to our list of known trackers, and then we just tie in, we make sure that this variable is equal to whatever we gave, right? Or rather, we do it in here, my mistake. We tie in this instance right in here. And we also give it the function that I talked about before, so we know what we're supposed to do. And then in here, when we do the daytime tracker, we're actually just saying, hey, tie this instance. So the instance should know that it has a tracker, right? And it should know what that tracker is so it can reference it. Meanwhile, the tracker should know what its instance is. They should know each other, basically is what we're doing here. So we tie these variables together. Now we've got some helpful little things. We have this function called datetime update. This is the one that will perform the events. You actually can have multiple events. We don't really use that. I forget. I think there's a couple places we use that, and that's why we added that functionality. So we have multiple potential events we could use. Otherwise, it's just a simple array. You can add more functions in here. That's helpful, right? So you can have infinite number of things to do whenever we want to update. And when we do the perform events, it's very easy. We just run through every single event and then we just call it. We just call the function as is. They can't take arguments. That's important. None of these can take arguments. We don't need them to. But if we ever decided that a function needs an argument, we need to rewrite it. We need to find a new way to do that. There's no data from outside can be passed into here. It's just calling whatever the code inside is. And that code oftentimes we'll just update the image data. It'll just say, oh, what's the current colors I need? Okay, well then change my color to this, change my color to that, and we're golden. Then from there, we have a simple for loop. We go through every single one of those datetime trackers that I stored in the list, and then we just call the update. And so this is what I'm talking about, where it's an opt-in system. This basically just goes through and says, okay, just run the updates for all the trackers. And so when the trackers update, they naturally go, okay, well, what's my linked object? That object will do some code. And so if you don't have a datetime tracker, you just never get checked in the first place, which means it ends up being a very efficient way of running through every object in the game, but not actually, because only the ones that wanted to get added get added. From here, same similar thing, we then go through all the trackers every now and then. I'll go over when we call this. We have a call system that goes through all the trackers, and we try to pull this object. If we can't pull it, if this object doesn't exist, then we destroy the tracker, because sometimes the object will simply cease to be, and we want the tracker to disappear alongside of it. We don't need it anymore, right? There's no object tied to it, and so this is how we get rid of those objects, right? Frees up some space. So these datetime trackers basically do the polymorphism that I was talking about. They are kind of like a wrapper for our system. So rather than just having a function and then going through every single object, instead we just have a secondary thing. We go through all of those secondary things. And those things, if they happen to have an object tied to them, they will handle it, which ends up just being much easier to work with because we don't have to write code for every object. We just have to add it where we want it. Again, it fits very well in our current systems this way. Now, what are we actually doing to call all this? Well, this particular code is only called in two places, right here and in a debug option I have to force it to happen if I need to test something. In this case, this is actually being called every time we want to change the time, right? So every time the hour changes, we go ahead and get the current hour. And then we say, basically what we're trying to say is like, okay, what's the current time? And then if we find like, okay, the current hour is greater than or equal to the time morning, time day, these are just some specific breakpoints. We're basically just trying to see what time it is and where you fall in line. And so if you happen to be between like, I think it's 5 and 12, is it? Something like that. Then it ends up being morning, right? That counts as morning. If it's 12 and 3 or whatever, then it ends up being day. I'd have to check again. And then from there, we just simply say, okay, if you're not the same as the last one, because if you're not the same as the last one, we don't need to update. Since this is called every time we change the time, then sometimes this will happen when nothing changes. We move from 5 to 5:04. It should still be morning. So don't bother trying to update things because this is kind of expensive. In the case where we do want to take a change, well, because we notice that this is in fact different, go ahead and mark down what our previous time was so we can compare and then update the color. So now when we actually do this, we jump into this thing. We set the timer, right? We have a smooth transition. It lasts for, I think it's 1 second exact. And then this is where we do the call. So first things first is we make sure we set our timer and then we remove any trackers that shouldn't exist, right? We have a bit of a weird one with a weather update because weather is built on a completely separate system besides just objects. I can't actually change the color of the weather. So I have to just stop it and restart it, which isn't really super efficient, but it works because it's just two of these and I have a to-do to maybe change that. And I'm not going to go into all the details of exactly why we have to do it this way. But again, this is just one of those things where it's like, okay, this system works differently. We have to change how we go about this. Stuff happens sometimes. when we actually want to get the color here, we have two big major functions that we're working with. The first one is this basic thing. This is where we're actually getting color. And we then have some shortcut functions to get specific colors, but as a whole, this is what's actually happening. Now we use another function down here, which is basically just a data table. Now there's a couple of ways we could have implemented this, but I decided a simple function makes it easiest. We're just going to run this. We create a struct that has 4 different variables, a base backing color, a text color, and then some high contrast versions, because some things we need extremely high contrast. We need a very, very bright color. In this case, we decided just black and white since it is grayscale after all. But we could theoretically have even more values at any point, and we will just add more shortcuts here to get those specific values if necessary. But as is right now, these are your 4, and that's all you really need. And from there, we then use this function to get what our basic expected colors are going to be. And in order to create this smooth transition that you see when we move from color to color, we actually are getting whatever the previous color is and what the current color is supposed to be. Then we go ahead and merge those two colors together based on a certain ratio determined by our timer. So I forget the exact math about this. It doesn't really matter too much, but it's something along the lines of like start at 0% previous and then move to 100% current, right? And whatever the specific, I think it's just a linear, but it might be, there might be something to it. Maybe it's, it moves faster at first or later on, or who knows what. But either way, we move from all the way of that previous color all the way to that current color by merging the two together, right? And then from there, we get this smooth movement. It's kind of bright now, and then it should go ahead and just smoothly transition in there. Now it darkens down. Now it completely transforms again, brightens up, so on and so forth. That will continue ad nauseum. And those base colors we work with are determined entirely by what time of day it is. And because we're only using 4 instances of day, now we don't actually have to worry about anything else. And I guess that pretty much does it for this whole system. I mean, that pretty much covers it. Hopefully you guys enjoyed. Hopefully you learned something. If you have questions, you could ask them in the comments. I'll try to get more into the groove of this whole style of video. I'll try to see if I can prep them a bit better. I'm sure this one was a bit hard to follow because, a lot of stuff is happening, but it's still entertaining, maybe, possibly, hopefully. Anyway, I'll catch you later.